to write a rule for these functions that we talked about in the last videos. If something is linear, chances are it's going to be a function. The only time that it would not be is if it was a line that was a vertical line going straight up and down. Then that's not necessarily a function that would fail the vertical line test. If we can write a rule for our functions, then we can model it. We can make graphs as large as we need to and work easily with very large numbers rather than having to necessarily rely on a graph. That's the nice thing about a rule. We don't have to rely on huge, big graphs to find out large values for x and y. There are three situations where we can be given information and have to write a function rule from it. I'm going to separate them into three different videos. That way, if you're struggling with the third topic, you don't have to watch the entire video, and you can go to just the video that you need. So we may be asked to write a function rule when we're given the slope and the y-intercept. I started with this one. This is the easiest one. If they tell us exactly what the slope is and what the y-intercept, it's a matter of plugging two numbers into our rule. In our rule, you can see over here, y equals mx plus b is the rule. In our rule, we're always going to keep, we're always going to keep a y and we're always going to keep an x. The m and the b change depending upon the situation. So if I were to start and tell you in a problem that the slope is 3 and the y-intercept, I'll abbreviate it, is 4, then you would simply take those values and plug them into the appropriate spots of the rule. If the slope is 3, well, slope is the m, and that always, always, always goes in front of the x. So 3x. And the b, I'm not sure why they chose b to stand for the y-intercept. I just know that they couldn't use y because y is already being used. And in this case, it tells us that the y-intercept, which is our b value, is a 4. Not only do I have 3 kids, but I have 2 dogs, so you'll have to excuse that noise as well. So that was easy. We have now a rule that we could use to determine any kind of points on that line that we wanted to. Let's say we want to make this graph and we want to know where the graph lands when x is 12. Not that we would have to do this, but let's just say, now that we have our rule, we can take our x value and plug it in here and find the y value that goes with it. 3 times 12 plus 4. Well, that gives us 36 plus 4, which is 40. So I know on my graph for this function, I would have a point way out at 12 to the right and 40 up. Do I have to graph that? No. I don't want to make a graph that's 40 units tall. But now because of the rule, I can determine the x and y value for any point that I might need. Okay, let's just do another one of those real quick because those are so simple and easy. Sometimes they might not write it out and say slope is 3, y-intercept is 4. It might say m is 1, b is -3. Sorry, the 3 is a little smushed together. So that makes it very simple. We have our y equals x. Now, it says plus in the rule, but if your slope or your y-intercept for whatever reason is not a positive number, you can change signs. It tells me my slope is 1, my m is 1. M always goes in front of x, and b always goes at the end. Now, because it says plus, that doesn't mean it always has to be addition. Because b is negative, I can just write this rule as y equals x minus 3. And again, then I can find any point that I want to on this line. Let's say I want to know the value for y when x is 0. Some of you might already know this. When x is 0 and I plug this in, I'm going to have 1 times 0 minus 3. 1 times 0 is 0. 0 minus 3 is -3. -3 was our y-intercept. When x is 0, that tells me I'm staying on the y-axis. So that's going to give me my y-intercept every single time. All right, so finding the y-intercept, or writing the rule when you're given the slope and the y-intercept is as easy as that. What if I had a slope that's negative? Slope is -1, y-intercept is 0. That's a little bit different scenario. You do the same thing. You still have your y equals, you got an x here, and you substitute the values into the right spot. M always goes in front of the x. You could write it as -1x like I did, or you can write it as -x. On Moodle, I tried to write the quizzes so that it would know to accept either situation. You could write +0 if you wanted to. You could write -0 if you wanted to. There really is no need to do that. Easiest case would be to write y equals -x. And that would be the function or the rule for our scenario where the slope is -1 and the y-intercept is 0.